So with Heisenberg's uncertainty principle, the idea is you can't know the exact position of an electron. So we do know that electrons reside in certain areas until they're excited and move out of that area. They sort of hang out in the same area, and we call that area an orbital space. We'll further define orbital here shortly. But since we can confine or consider the electron to hang out in this area, that kind of helps us with our calculations and understanding of the electron. Here's a little clip from the Big Bang Theory that kind of gives us a real life example of the uncertainty principle.
Oh boy.
What?
I can't comment without violating our agreement that I not criticize your work.
Then what was oh boy?
Great restraint on my part.
There's nothing wrong with the science here.
Perhaps you mean a different thing than I do when you say science.
Okay, how's that?
You actually had it right in the first place. Once again, you've fallen for one of my classic pranks. Bazinga. Well, now here's a peculiar email. The president of the university wants me to meet him at his office tomorrow morning at 8 a.m.
Why?
Doesn't say. Must be an emergency. Everyone at the university knows I eat breakfast at 8 and move my bowels at 8:20.
Yes, how did we live before Twitter? I guess you'll find out what it is in the morning.
Well, it's 14 hours away. For the next 840 minutes, I'm effectively one of Heisenberg's particles. I know where I am, or I know how fast I'm going, but I can't know both. Yet, how am I supposed to carry on with this huge, annoying thing hovering over my head?
Yeah, I know the feeling.
To know the location of an object, we have to be able to see it. And when we see something, what we're actually seeing is light waves reflected off of whatever object it is. And light travels, we've learned, in these packets of energy called photons. Now the electron, imagine this, is so small that when light hits it, it actually alters its path. So when these photons of light hit the electron, it changes the movement or path or position of the electron. So if we are measuring position of the electron, its velocity will change. If we measure its velocity, its position will change. So that means there's always some element of the location or the speed and the direction at which the electron is moving that we are unsure about. So that's the whole idea of the uncertainty principle, because once we measure it, we alter it, or once we observe it, we alter it. The electron cloud is named that way because when you look at it, it actually appears like a cloud of electrons rather than being able to see individual particles. It's kind of similar to a fan, whereas if you have it turned off, you will see the individual blades. But when you turn it on, instead of seeing 3 or 4 individual blades there, as it rotates at a high speed, it kind of looks like a cloud inside there. It's all blurred together. So that's the same idea as how the electrons would look like if you look at them actually moving around the electron cloud. A lot of times when we draw and depict atoms, as we're teaching you about electrons and energy levels, we tend to draw those in a circular format. And that's great, and that works well because there are layers around the nucleus of the atom. But it kind of gives you maybe a false idea that all atoms the electron clouds are all spherical in shape because they are 3-dimensional objects instead of 2-dimensional and flat. But the shapes of the electron clouds can be quite different depending on where the electrons are located, what energy levels those electrons are in. There are spherical subshells or orbitals in the atom, but there are also some that look like the other 3 here at the top row, and those are referred to as a dumbbell shape. And then there are some that it gets very bizarre the higher energy levels you go into, you can see the shapes are quite odd. In a moment, we'll see a clip from my favorite professor there in England where he'll show you actual models of some of the different views here. These are just X-ray images of those.